Well, hello. Welcome to More Math. It's good to see you again. Hey, please be sure to get a piece of paper and a pencil. Why? Hey, watching is just boring. You want to join in and work with me. All right. You're going to learn more. Do you remember last time? What did we talk about? We talked about GCF, the greatest common factor. Today, we are talking about the LCM. What is that? That is the least, the smallest. What does it mean? Least means small. Common, it's the same. Everyone has the same. And multiple. That's like when we multiply. But it's also like skip counting. Do you know skip counting when you count it through? You go 3, 6, 9, 12. It is skip counting. So today, we're going to talk about how we find the least, the smallest number that they have in common. All right, I'm going to show you. For example, if we did some skip counting, let's say we use 3 and 4. That'd be easy. So 3 when we're skip counting 3, how do we do that? We say it's 3, 6, good. So 3, 6, we add 3 more. What do we get? 9, good job. We're going to add 3, get 12. And let's do it one more time. Good, 15. So we just keep adding 3. We add 3, we added 3, we added 3, right? Or we could say 3 times 1. That equals 3. 3 times 2, that's 6. 3 times 3, that's 9. 3 times 4, got 12. You see what we're doing? Do you see the pattern? All right, good. So that is the skip counting. So let's try it again. I would like you to do it on your paper, please. Would you write down the skip counting for 4? So write the skip counting, okay? Hang on, pause the video so you have time to do it. All right, welcome back. We're going to write 4, add 4, get 8, add 4, we get 12, add 4, 16. All right. When we talk about a multiple, we say 3, 6, 9, 12, 15, and goes on, and we're adding 3, right? We say 4, 8, 12. What? 12? Shh. Hey, look, there's a bird over there. Look over there. What do you mean you saw 12? That's not a 12. That's 16. You're so silly. All right, moving on. 4, 8, 12, 16. We're adding 4 each time, right? All right, good job. So these multiples, let's check these words now, see if we understand. The least, the smallest, common, the same, they both have it, and multiples. Here's the multiples, right? We see these examples here. Let's find one that they both have. 3, nope, they both don't have 3. 6, do you see a 6? No 6. 9, 9's a good number. Sure, it's going to have a 9. No 9. Let's try 12. 12, there's one. Hey, good job, look at that. Here's a 12, there's a 12. They both have 12. 12 is the first number. That means it's smallest that they both have. 12, 12. It is common. It's the smallest common, the least common multiple. Oh, that's what that means. Okay. Now let's try it another way. All right, now let's try it another way. Remember last time we talked about GCF? Yeah? We're going to use the same idea now. So we're going to write the skip counting. We could do that. But sometimes when you have bigger numbers, it gets harder. It gets harder to see. So we can use something easy. How are we going to do that? We're going to use upside down division again, like we did with greatest common factor. So we're going to write the number 12 and the number 18. We're going to put that upside down divisor here. Now remember, we want to find a common factor. Do you remember that from last time? So what number can we divide out of both 12 and 18? Well, we always start with 2. I always start with 2 because it's easy. Do you remember how we know if a 2 will divide out? Yes, right. If it is an even number. Are these both even? Yes, they are. Why? What are the even numbers? The number at the end is even. It's 2, 4, 6, 8. Hey, who do we appreciate? Not 0. 2, 4, 6, 8, 0. If it's 2, 4, 6, 8, or 0 at the end, we know that it's even, and then we know that we can divide a 2 out. So let's do that. So we're going to put a 2 here. So this 2 on the outside, 12 divided by 2 is, nice, it is 6. 18 divided by 2, good job, 9. All right, now let's look at it again. I don't think I'm done. I know 9 is not even, so I can't divide out a 2. So 2's are done. All right, let's try the next one, 3. Yep, 3. 3 will go into 6, and 3 will go into 9. All right, let's do that. So we're going to divide out a 3. What is 6 divided by 3? Good. It is 2. 9 divided by 3? 3. Oh. Do you remember last time we talked about that if we have counting numbers, if the numbers are right next to each other, like 2, 3, 7, 8, 12, 13, that if these leftovers are right next to each other, we're done. There's no more common factors. So we know that we are done. Good job. All right, so we remember, we're going to practice real quick, the GCF right here. The GCF is what? 2 times 3, which is 6. It is the greatest common factor, 6. But, well, that's not what I want today. Today I want to know what is the LCM, the least common multiple. We are going to use this exact same thing. Watch this. Well, do you see my great big L? Do you see it? The L, the least common multiple. We're going to multiply all these numbers together. Let's try it. So we're going to say 2 times 3. That's the GCF. We saw that already. Times 2 times 3. That's the leftovers. You know, like last night's spaghetti. Do you remember that we use a dot now when we talk about multiplying? We're not going to use an x. Why don't we use an x? Because later, an x is going to become a variable, and it's going to get confusing. So right now, we're going to practice using the dot when we multiply. All right. So let's multiply them all together. Ready? 2 times 3 is what? 6. Good. Times 2 is 12. Times 3, 36. All right. The LCM is 36. All right, well, that's nice, but honestly, why do I care? I'm going to show you. Let's say I had some boxes. So this one's 12 inches tall. And those boxes are 18 inches. and I want to stack them up. I want to know how tall are they going to be when they're going to be even. So I have 12, 20, 40, 24, 36, 48, 18, 30. How tall will it be when these two are even? They're going to be 36 inches. Let's take a picture. Let's make a picture of that. So let's draw a picture. That's 12 inches. One box. Remember, not an art teacher. What can I say? It's 12, 24, 36. So we have 36 inches of boxes here. So the 3, it kind of goes across, right? So if we have 3 of the 12 inches, it equals 2 of the 18. Here we have it. So we know now that they are going to stack up, that they are going to be the same height. They are going to be level at 36 inches. That can be useful. Let's try another one. Wait a minute. There's 3 numbers now. That's so scary. Nah. Easy peasy. We're going to do the exact same thing. Let's do it again. We're going to pretend that we have 3 trains. We've got train A. It arrives at the station every 12 minutes. Train B arrives every 15 minutes. And obviously, train C shows up every 18 minutes. He has to go out farther. How often will they arrive at the same time? Let's find out. With these 3 different numbers, it's still going to be easy. Watch. 12, 15, 18. Did you draw that on your paper? Good job. Let me know. What number do you think we can pull out? Can we pull out a 2? 12's even. 18's even. Oh, 15 is not even. We can't use 2. It has to work for all 3 numbers. So we can't use 2. Will 3 work? Yeah. Yes. And yes. All right. Good job. We're going to try 3. So 12 divided by 3. Good. It's 4. 15 divided by 3. 5. And 18 divided by 3. 6. Well, we're done. There's only one number that we could divide out. That's okay. So if there's only one number we can divide out here, it makes it really easy to see the LCM. Okay, where's the L? Good job. Here's that L. Now we're just going to multiply them all together. 3 times 4 times 5 times 6. So remember, you can use a calculator. That's totally fine. All right, what'd you get? Good job, 180 minutes. So every 180 minutes, all 3 of the trains are going to show up. Well, how many hours is that? Let's see. It's 180 minutes. We're going to divide it by 60 minutes in every hour. We'll talk about that more later, how we got the answer, but it is 3 hours. All right, so all 3 trains are going to arrive every 3 hours. Well, why do I care about that? Well, I don't know, maybe I want to sell something. If I'm going to go to the train station, if I'm going to go sell something, I want to go when there's many people there, right? I want to go every 3 hours because I know there's going to be lots of people there that might buy my stuff. Okay. Yeah, I know every 3 hours there's going to be a lot of people at that train station. All right, good job. So the last idea I want to teach you now, we're going to talk about fractions. We're going to use LCMs and fractions too. Why? Let me show you. We'll learn more about it later, but I just want to introduce this to you. If I want to compare 5/6 to 7/10, which one's bigger? I'm not sure. Why can I not be sure? Because I don't have a common denominator. It has to be the same in order for me to really compare them. So I need to know what is the LCM of 6 and 10. So let's see. Six. Remember, we can use skip counting, or we can use the upside down division. Either one, they both work. 6, 12, 18, 24, 30, 10, 20, 30. So I know I could stop at 30 because I knew that was it. So we know that the LCM is 30. Okay. So the LCM equals 30. Whoop, wrong color. 6 times what would be equal to 30? 5, good job. All right. I can do that. Can I do that? Yes. No matter what I do on the bottom, if I do the same thing on the top, I'm allowed to do that. So I just need to multiply the top by 5 also. So 5 times 5 is 25. Good job. All right, let's do the same thing here. 10 times what's going to be 30? You got it. 10 times 3. So again, I can do that. But if I multiply the bottom by 3, I have to multiply the top by 3. So what is 7 times 3? So now we got 21 over 30. So now I can compare them. They have the same denominator. 30 is the denominator for both. So 25 is bigger than 21. So which one's bigger? The 25, right? It's bigger than 21. So I know that 5/6 is bigger than 7/10. We can compare them now. We're going to learn more about how to do that, but I wanted to show you that we're going to use LCM when we're working with fractions, and we'll use it often. Thank you for joining me today. I hope you did a wonderful job. You did a really good job. I can sign, really, promise. Anyway, I hope you have a wonderful day. Love you. See you next time.